So this is part 2 of section 8.1, and we are now going to be looking at series. And series are what happens when you add up all the terms of a sequence. So we're going to say the sum, because we're mathematicians, of the terms of a series. And what happens when we go ahead and we talk about series is that we often talk about them in sigma, or also known as sum notation. Sigma or summation notation. And that's because we use sigma, and sigma is a Greek letter here. So sigma is kind of like this weird, funky E thing that we have going on here. So when we use sigma, we have some things that we talk about. So this one, would go ahead and we would talk about sigma, and we'd have a little lower bound here. I'm going to label these for you in just a second. We're going to talk about I plus 1. Okay, so this is what these terms mean here, is that this is our lower bound. So this I is equal to 1 is called our lower bound. And the lower bound is where we're starting from. So on this example, we're starting at the first term. And then we also have our upper bound. So this 5 is our upper bound. And this is where we're going to. So we're going from the first term to the fifth term. Now, of course, we also have this rule in here, and I'm going to go ahead and I'm going to highlight our rule. So that's the rule that we're using, or the series. So we're going to use that one. Now, for this guy, we can go ahead and add these up here. So we're going to say that this is equal to, we're going to start with our first term. So our first term is 1 plus 1. And then we're going to add that to our second term, and our second term is 2 plus 1. And then add that to our third term and our fourth term. And we, of course, our upper bound is 5, so we're going to our fifth term. Now this one's pretty simple. We would say that this one we can go ahead and equal to, we have 2 plus 3 plus 4 plus 5 plus 6, and when we add all of these up together, they equal 20. So the answer to this problem is 20. Now, this is what we go ahead and we call finite because it is ending. So this is an example of a finite series. All right, and a finite series, because the terms end, it has a nice upward bound. Now there's also the option of an infinite series. Switch colors here. So we might have the ability of an infinite series. And when we have an infinite series, we kind of write it here. I have my sigma, and I'm going to say I'm starting at 1. Maybe my pattern is 2i, but I write the infinity sign as my upward bound. And that little infinity sign up here makes this an infinite series here, meaning that you're going to go all the way up to infinity. Okay, so let's go ahead and let's practice a few of these, finding these sums. So we are actually on example 3. Okay, and I am going to give you a series. So I'm going to have 5 plus 10 plus 15 plus some numbers in between And I'm going to say my last term is 100. Okay, now the first thing that I need to do is I need to write this in sigma notation. So we're going to go ahead, we're going to write in sigma. All right, so we're going to write it in sigma notation. And the first thing with writing it in sigma notation is giving yourself that little sigma sign. Sorry, mine get a little funky from time to time. Not sure if they need to be that long. There we go. Okay. Now, the first thing here is that I want to go ahead and I want to see what my terms are. So, just like we did before, I'm going to switch colors here. I have a sub 1, a sub 2, a sub 3, and then this is going to be an a sub something. I'm going to put a question mark here, but this definitely ends. I just need to figure out what that ending point is. So I know I'm starting at my first term here, so I'm going to say that I'm starting at my first term. Now, if you notice, this is actually a linear pattern because the difference here is 5 between them. All right, so my linear pattern ends up being with a slope of 5, meaning that I have 5i for my pattern. Now, I just need to kind of figure out where the heck does this end? At what term is it ending? So you can go ahead and you can set this up for yourself and you can say, okay, well, this is going to be my last term. It's 100 and it's equal to 5, whatever my term is. You can all do this math and you get 20 is equal to I, meaning that this is a sub 20, meaning that my upward bound is 20. Okay, so this right here is my sigma notation. I'm going to go ahead and I'll kind of highlight this all in orange. So this guy, all right here is my sigma notation. Now we need to go ahead and we need to solve for it. Now we have a few options in terms of solving for it. I'm going to just rewrite it over here on the side. So we have our sigma with an upward bound of 20, we're starting at 1, and our pattern is 5i. Okay, option 1 is that we could go ahead and we could just add up all these terms. Sounds pretty boring. Now, if you kind of checked your book here, there's a few formulas that you can use. And one of the formulas that I want to point out about this one, and this is on page 413, is that you have your sum of your first positive integers, which we are going to go ahead and state here for you. And this says that if you're starting at 1 and you have I in the middle here, you're going to your nth term, that you can actually take your n number, so your n, whatever term you're going to, multiply it by that plus 1 over 2. So you can actually use this formula here. Now, if you'll notice, our formula is just a little bit different than our actual formula over here. So what we are going to have to do is that we're going to plug this in, but we're going to multiply it by 5, meaning that we can take 5 times, now we're going to our 20th term, so we would take 20 times 20 plus 1 over 2, and you can go ahead and you would do this in your calculator, which would mean that we would get 5 times 210, which means that our sum is 1050. Okay, so there's a cool way that you can go ahead and you can check this in your TI-83. Or TI-84, and I will show that video a little bit later. Okay, let's do one more example for you. So we are on example 4. Feel free to pause this one if you want to try it on your own. So I'm going to end at 7, but I'm starting at the third term, and my rule is k squared minus 1. Now, this one takes a little bit of work, but I find that the easiest way to do this is that because you're only going from your third term to your 7th term, I'm just going to go ahead and I'm going to write this out. So I'm going to do a little bit of work in my head here. So I have 3 squared minus 1, that's 9 minus 1, so 8. It's my third term. Plus, all right, I have 4 squared minus 1, 15. That's my fourth term. Plus 5 squared minus 1, 24, fifth term. Plus, let's see, I'm on 6. 6 squared minus 1, 35. And my very last term, 48. Now, when you go ahead and you add up all of these together, you get 130. And here is my answer. Now, again, there's a way to check this. So I'm going to check in my calculator. Calculator. And I'm going to show that to you in a different video.